All right, so now we have question 2 on our arithmetic and quadratic formula. So the first term of an arithmetic series, they say, is 7. The common difference of this series is 5, and the series contains 20 terms. Now, 2.1.1 is saying calculate the sum of this series. So to calculate that, we are going to just say Sn is equals to n over 2, and then 2a plus bracket n minus 1, and then we have d like that. So how many terms do we have? That's 20 over 2, and then our first term, they said, is what? 7, and then here we have 20 once more, and then multiply that by 5, close bracket. Then you're just going to punch all of that into your calculator. You get that the sum of 20 terms will give us what? 1090, right? So that's it. You're just going to get a mark for the substitution and the correct answer. Okay, then we have 2.1.2, which says the original arithmetic series is extended to 75 terms. What are they saying? It means from the 20 terms, they're now adding a certain number of terms to make it 75 terms. So if you can quickly do the maths, 75 minus 20, that means they added 55 more terms, right? They added 55 more terms. Now, if they add those 55 more terms, now the sum of this whole 75 terms now make 14,400. They're now saying, using sigma notation, write down the equation for the sum of the terms added to the original series. So this is what we're going to do. We understand that in order to find the difference, we'll have to say sum of 75 minus the sum of what? The sum of 20 terms, right? And then what are we going to get there? The sum of 75, we've been given that it's 14,400, and then we calculated the sum of 20 terms is only 1,009. So the difference that is made by the 55 terms is 13,310. So how do we then write this in sigma notation? Remember, with sigma notation, you need the general term, right? You need your nth term. So this is Tn is equals to a plus n minus 1, and then d. Remember, we are still using the same arithmetic series. Our a value is 7, and then we have n minus 1. Our d value, they said the common difference is 5. So we're going to have 5 here. So this is going to be 5n minus 5 and then plus 7, which is going to give us 5n plus 2. So that's our Tn. Then when we write the sigma notation, we're going to write it like this. We're going to say if our n starts from 1, then it must run all the way through until the 75th term, right? So until 75. But then what is the general formula guiding that? It's 5n plus 2. And then we have to subtract that. Remember, we are writing this. Our n starting from 1, but then only ending at what? At 20. What is the general formula guiding that? It's 5n plus 2. And then this gives us what? 13,310. Right. So this is how we write it in sigma notation. But then still you can simplify it further to say that the difference here, the 13,310, will start from all the terms from T21 all the way to T75. Now, how do you express that? That means the subtraction here will now have to give you what? Where your n is starting from 21 all the way to term 75. Which if you're going to do this, you will find that it's exactly 55 terms. Then this is going to give us what? 5n plus 2, and then this is equals to 13,310, right? So that's basically how you go about it. So if you want to confirm that it's that, your number of terms is upper value minus lower value plus 1, right? So let's see if it's going to give us the 55 terms. Your upper value, 75. Now it has to start from term 21. So minus 21 plus 1. Remember, it ended at term 20. So when it starts, when they add the 55 terms, they're adding from 21 all the way to 75. So the 75 minus 21 is 54, and then plus 1, that's 55 terms, right? So which confirms that this is correct. Right, so that's basically how you were supposed to write that. That's basically how you were supposed to indicate all of that. So there was going to be a mark for the general formula. because you need it. There was going to be a mark for subtracting this, and then there was going to be a mark for having to be able to write it in sigma notation, and then finally being able to express it like this, right? So, okay, now you have how many marks? There was 4 marks, yes. 2.2 says the sequence of the first differences of a quadratic pattern is 1, 3, 5. Note this, the sequence of the first differences, not the quadratic pattern itself, but then the first differences of the quadratic pattern is 1, 3, and 5. Now, if T99 of this quadratic pattern is 9,632, calculate the value of T92. Now, you will always realize that if I have this, if I have a quadratic pattern, and then let's say this is the value of the first difference is 1, 3, and then 5, right? And then obviously second difference will be what? Will be 2. Now, if I want to get T1, right, you will realize that it's just a matter of saying T2 minus this value here. So whenever I get this second term minus the value from the first difference in my quadratic pattern, then I get T1. Also, if you want to get, let's say T2, you'll have to say T3 minus the value in here. It will give you T2 all the way like that. So that's the knowledge we'll be using. So in other words here, what we'll be trying to find here is, let's find the pattern that is created by this, right? 1, 3, 5. Now from here, we can already see that our common difference, remember the first difference, the one important thing that you have to note about the quadratic pattern is that the first difference always gives birth to the arithmetic sequence. If you can look at this, the first difference of your quadratic pattern is actually an arithmetic sequence. And then the second difference that you are seeing here is actually what we refer to as what? As the common difference in an arithmetic sequence. So always note that when they bring about a quadratic pattern, it is usually to hide the arithmetic sequence, right? So this is 1, 3, and then 5. Now we know that this, we want to take it as the common difference. This now will become our what? Our value here, right? So this will be the first value. So that means we are going to have Tn is equals to A plus N minus 1, and then D. Our A value is 1. And then we have N minus 1, and then our D value is 2. So this is 2N minus 2, and then plus 1. Then our Tn will be equals to what? 2N minus 1, right? But then remember, what are we trying to find? We are trying to find T what? T98. So we are being told if T99 of this quadratic pattern is this, then calculate T98. So let's see, T98 will be equals to 2 multiplied by what? By 98 minus 1. Whoa. Minus 1, like that. 2 multiplied by 98 minus 1, this will give us 195, right? Remember, this is the T98 from the what? From the first difference. From the first difference. What we are trying to calculate is T98 from the what? From the quadratic pattern. So this is what we're going to do. And I say to get T99, the same way I've been saying, to get T99 now, I would have to say what? I would have to say to get T98, I would have to say T99 from the quadratic minus T98 from the what? From the arithmetic, or from the first difference. Same way I've been saying, if I want to get T2 here, I would have to say what? T2 is equals to the T3 here, and then minus what? The T2. The T3 from the quadratic, and then the T2 from the arithmetic. So that I get T2 of what? The quadratic. T98 of the quadratic, T99 of the quadratic, minus T98 of the arithmetic. So this is going to be what? 9,632 minus 195. And then what do I get? 9,437. So that's my T98. Right. There we go. Okay. So let that sink in. Let that sink in. So it's very important that you note that. It's very important that you note that. Whenever we are looking for something that has to do with the quadratic T2, then it's T3 of that quadratic minus T2 of the same arithmetic. Okay, then we have this 5 marks here, 2.2.2. It says it is further given that the third term of the quadratic pattern is 32. Okay, so from that first difference, we have 1, and then we have 3, and then we have 5. Now we are given that this will be T1, T2, and then T3, right? So we are given that this one is 32. Now, using the fact that I've been telling you, if I want to find T2, I must say 32 minus 3. And then I get what? 29. Let's say I want to find the T1, I must say 29 minus 1. And then I get what? 28. So that's the quadratic pattern. And then obviously, if you want to continue with it, you can say 32 now plus 5 to go to the next one. All the way like that. If you say 32 plus 5, that's going to give us what? 37. And then obviously you can see that here, what will follow here is what? 1, 3, 5, and then 7, all the way like that. So still here, your second difference is 2. Your second difference is 2. Now, what are we supposed to do? Determine the general term, Tn of the quadratic pattern. So now we want Tn of the quadratic pattern. How do we start with that? We know that this should always be equated to what? To 2a. And then this equated to 3a plus b. And then this be equated to a plus b plus c. And then we only use the values of the first branch. The values of the first branch. Let's go now. We have 2a is equals to 2. Divide by 2, divide by 2. Our a value will be 1. And then 3a plus b is equals to 1. So where there is a, we're going to replace by that 1. And then 1 here. B is equals to 1 minus 3, which means our b will be equal to negative 2. Now for c, I have a plus b plus c is equals to 28. So that's 1 minus 2 plus c is equals to 28. So 1 minus 2, that gives me negative 1. So c will be 28 plus 1 now. So c is equals to what? 29. So that means my Tn in the form of an squared plus bn plus c will now have to be what? My a value is 1, so I'm just going to write n squared. My b value is negative 2, so that's negative 2n. And then my c value is 29. And then there we go, 5 marks. I now have the equation. So where do we get our marks? The second difference, being able to find that our a is 1, our b value is negative 2, our c value is 29, right? And then being able to come up with the equation, obviously. So that is it. 1, 2, 3, 4, 5. Okay, so you have 14 marks in the bag, just like that. Awesome.